as a resource. As a result, things like overexploitation, depletion, pollution, and others are becoming major problems in the groundwater resources. So now this initiative is giving a lot of attention now to groundwater as part of our efforts and supporting the countries to better manage and develop the water resources. And giving a lot of attention to groundwater. That is how groundwater ends up being a major theme for this NBDF. The theme for the NBDF is around investments, and the same applies for the groundwater sessions. The whole idea is how can the knowledge and science behind these resources be leveraged to promote more investments in the basin, in this case, for groundwater. So we are asking questions like, what are the trends, what are the main barriers to groundwater development, what are the innovative approaches that we can use to better understand the resource? What are the tools and options that are available for sustainable management of especially transboundary groundwater, but also the policy options that can be adopted by countries at national and transboundary levels. So yesterday we had the first session, which really concentrated around issues of challenges and opportunities for groundwater exploitation. There are a lot of examples, very interesting examples for those of you who attended, on the successes and failures that have been experienced in groundwater exploitation. Now, today we want to transition and look at some novel approaches and tools and methods that can be used for the management of groundwater resources. And we have a very good lineup of presentations for this. Start with, we will have a short presentation from Dr. Maha Rahim, who is managing a project at Nile Basin Initiative on enhancing the conjunctive use of groundwater and surface water in the Nile Basin. She will make a short presentation about this. This will be followed by a presentation by Professor Abdin Salih on his experiences in the groundwater area and looking at especially issues of groundwater and surface water sustainable use. We have a presentation from Dr. Jamal Sidahmed, but I think he's still missing. This will be followed by a presentation from Dr. Christina Frazier from IGRAC, followed by a presentation from Dr. Masa Mukla from United Nations University, and finally a presentation from Dr. Rosemary from IHE. So without further ado, I'm going to request Dr. Maha to make her presentation. It's supposed to be 10 minutes.
Thank you, Michael. Today I'm going to talk about the project which has just been launched in NBD, Nile Basin Initiative. This is the first groundwater project to be launched in Nile Basin. And in general, as Michael said, groundwater has received little attention, although it forms most of the water used either for drinking or domestic purposes or for irrigation. But little attention was steered towards it. This project is going to concentrate. Next slide, please. Yeah, so you see more than 60% of the rural population uses groundwater, and more than 70% of the Nile Basin countries' population are living in rural areas. And groundwater is not well defined as is not well defined, and it's the only consistent source of water for many communities outside or beyond the Nile corridor. There is another problem: is most of the drilled wells in rural areas are of traditional origin and traditional construction, and mostly has no records of abstraction or quality or quantity. There is limited understanding for aquifers. This is when it comes to challenges. Lack of monitoring, sustainable management is a question also. There is no tracking systems, especially when it comes to transboundary groundwater, pollution, susceptibility, contamination, and then sustainable management and policies and legal framework. These are all challenges that puts groundwater on risk. Next slide, please. This project is unique as it focuses on selected aquifers. It doesn't look at the entire basin groundwater. No, we have concentrated on 3 aquifers, 3 shared aquifers, which is the Gadarif Adigrat aquifer, which is shared between Ethiopia and Sudan, Mount Elgon, which is shared between Kenya and Uganda, and the Kajera, which is shared between Burundi, Rwanda, Tanzania, and Uganda. The budget for this project is $5.3 million USD, and it is funded by the GEF and the UNDP. As you can see, this project is made up of 5 components. The first one is about knowledge and understanding. Of course, you can't manage anything that you cannot understand or assess. So the first one is to understand and assess the resource itself, and then to develop action plans. This is component 2. And then we come up with pilot projects. And then component 4 is to pinpoint areas of weaknesses that needs further strengthening, whether on capacity or whether on development or whether on sustainability policies and so on. And then component 5, which is the major component, which is supposed to be running with, or it is already running all over the 4 components, which is communication and awareness raising, because you know visibility and sharing the knowledge and the experience with the different countries on the good practice and success stories is very important in developing a shared vision for management of the joint aquifers or the shared aquifers. Thank you. This is all. Thank you very much. Thank you, Kiza.
Okay, thank you, Dr. Noha. This presentation is intentionally very short. For those of you who need more information about it, and definitely there are lots of groundwater experts that will call on to participate in this project, we can always get in touch. The second thing is that there is a chat for participants who have questions they want to ask. Please post your question in the Q&A. Down there, there's a box for Q&A, but also you can raise any topics within the chat itself. Okay, so that I hope that is clear. Now we'll move on to the presentation by Professor Abdul Saleh. Over to you, Professor.
Thank you very much.
Project, and thanks for inviting me to the virtual launch. I was really happy to participate.
Okay. Good morning, everybody. I'm coming back again also. Yesterday, I talked a little bit about things related to Unesco. I thought this time I will share with you some of my experience on groundwater investment and what type of problems could happen. And so I thought I better concentrate in my experience. Are you following me?
Yes, you can put your presentation here in presentation mode.
Do you see it now? I put it there. Do you see it?
Presentation mode, there's a box that you have to click on.
Presentation.
Slideshow.
put it
Put
in
it on the
presentation, please.
slideshow, Professor, put it on the
Presentation.
slideshow.
Yeah, okay.
Slideshow after animation.
Yeah, I'm trying.
That ribbon move right.
Up, go up.
Right.
Yeah, so while we are doing that,
Okay.
as I said, I would be sharing with you my experience on groundwater. Where
Yes.
is it okay now? This way?
Yes.
Is it all right? Okay. Okay. Groundwater, as we all know, groundwater is one of the most important and most vulnerable of Earth's natural resources. Key advantages of groundwater to surface water: it's higher quality, better protected from direct pollution, less subject to seasonal and perennial fluctuations, and much more uniformly spread over large regions of the world than surface water. And as I showed yesterday, also its presence in the global water is also much more than other form of water. In arid and semi-arid countries, groundwater is widely used for irrigation, which uses a lot of water. About 1/3 of the world's land mass is irrigated by groundwater. In the USA, 45% of cultivated land is irrigated by groundwater. In Iran, Algeria, Morocco, and many other countries, the share of groundwater is 58, 67, and 75% respectively. In countries like Libya or Tunisia or Saudi Arabia, before they developed a lot of desalination, groundwater is the only traditional source of fresh water. Around 2,500 to 3,500 billion cubic meters of groundwater are annually renewable, out of which only 750 to 800 billion meter cube per year are currently used. Most of the 750 or 800 billion cubic meter per annum of global renewable groundwater withdrawal are used for irrigation of agricultural crops. During the last 2 decades, there has been a significant increase in the use of groundwater for irrigation, particularly in India, the USA, China, Pakistan, Iran, and Mexico, as the largest consumers of groundwater. The growth in using groundwater for irrigation started in the 50s with innovative development in tube wells and pumping technology, where from 1960 to 2000, the annual groundwater use increased 3 times. This map just shows the groundwater resources of the world. It shows the major groundwater in areas, and the different colors shows different aspects of groundwater. Also, the table which is here give an idea. The numbers could have changed, but as an order of idea in the world, total irrigated area, you can see 300 millions, over 300 millions of hectares. And if you want to see the percentage in the world, why is the use of groundwater, and you will find that Africa is only 2.3% represent the use over the world, while Asia, as expected, is almost 71%. And so there is quite a bit of room for Africa to improve the use of groundwater. There are some challenges of groundwater use in agriculture. In fact, there are even challenges in the use of groundwater for other aspects like domestic or industrial aspects. Overexploitation, leading to many groundwater reserves being depleted. Impermeable environmental degradation to aquifers, threatening long-term sustainability. Contaminations that could threaten the existing drinking water sources. Climate and global change, they have quite a bit an effect. Most groundwater irrigation is managed by private sector or informal sector, and it's largely unregulated. And this is happening in many countries, including my country, when people are using non-renewable groundwater. And we insist that it should have been with monitoring, a strict monitoring aspect to be governed by the government. Operation and maintenance is also a great problem. Luckily, in the SDGs, there are aspects which allow us to look at how to use it well. For example, SDG 6 target 6.4, it looks that by 2030, substantial increase in the water use efficiency across the sectors and ensure sustainable withdrawals and supply of fresh water to address water scarcity and substantially reduce the number of people suffering from water scarcity. Best practices for regulation, policies, and implementation are in developed and industrialized countries, unfortunately, and communities with scientific resource and institution capacities. In other countries, we go and use groundwater, but without having the basic knowledge to avoid we lose this water through contamination or through over abstraction or other. I thought from here on, I will share with you some of my experiences in relation to this subject. And I will start my experience in USA, Saudi Arabia, Iran, Libya, Unesco, and Sudan. In USA, I went there in 78 as a visiting professor to Colorado State University. And I worked, in fact, I was supposed to go to Iowa, but I changed to Colorado because they said they will give me a job. And so I went there and I worked with Professor Evgevich in a very interesting project. And the project was the American Spanish project on conjunctive use. At that time, the word conjunctive use is the buzzword. That is surface and groundwater. You have to look to sink in. And they gave a great professor, one of the best professors, I think, always the students like him, Professor Makorta, to look after natural recharge in this project. And I looked after artificial recharge. And for 1 year we worked, and this made me so close to groundwater. And I think maybe I reviewed everything related to artificial recharge in the world. And I made a sort of a document on artificial recharge and its way uses, the way where you can use it, how you could link artificial recharge with the groundwater without. And luckily at that time when I was in the USA, it was 78, 79 was really a time where Colorado State University had the best professors, I think, in the world at that time. And then there are things going on like the Ogallala Formation, which is a great aquifer. And I remember in Texas, it is used extensively. Texas has, at that time, a lot of economy. I mean, they have the petrol, they have the huge agriculture using the Ogallala Formation. But unfortunately, the aquifer started to deplete and the water started to reduce the level. And it was a great problem in the circle of the scientists and the circle of the professionals in the area of groundwater. And what should they do and how could they solve this problem? And they thought a lot of things. At that time, also water harvesting is not as large as now, but they thought of water harvesting using playa lakes. They thought of introducing water for a neighboring state, which wasn't very easy at the time. I don't know why is it. The playa lakes are just like pools, when also they collect rain, but it turned out to be a very bad recharge method because of the sediment which will stand down and it makes the recharge very poor. At that time also appears the coastal aquifers and problem related to coastal aquifers and what should they do to reduce the problems related to invasion of seawater to coastal aquifer. And a great person at that time was Professor Asano, and I met him personally, and I was so happy to see the solutions, which innovative solution at the time they tried to think of to reduce the invasion of the seawater toward the coastal aquifers. And they thought of using water reuse, you know, the wastewater, which they put it to make a barrier between that, and so many interesting solutions at the time. All this made me very close to groundwater and very close to what is going on and what type of a problem to it. And also, of course, from that, I got the lesson of that poor recharge is the poorest. And this led me to my trip to Saudi Arabia. So in 1980, I was asked by King Saud University to go for a couple of periods from the University of Khartoum to the King Saud University. And the first thing I usually, when I go, we start to do research related to the country which you go to. And I found that there is a madness to our establishing recharge dam in wadis to recharge the aquifer, neighboring aquifer. And everybody in each part of the country, they want a dam to be built. And Riyadh stands in central Saudi Arabia, and it was the capital. So with two of my colleagues, Professor Tarbag and Professor Fadel Mutair, we made a proposition to CACST, which includes City for Science and Technology, the largest research entity in the country. And we applied for a project, and because I told them, are you mad? How could you use recharge in dams? This is poor recharge. The water will pour around the dam, and then its silt would be there, and it would be a waste. And with your sun and high evaporation, you lose the water. This is not a good way to do. Anyway, this is the idea which I have when I came from USA. And so we started in this project. In fact, we did survey to tens of projects in central Saudi Arabia, within Riyadh district, Riyadh area, all the dams. We studied them to see, is there really any chance? Where are those people are mad about having such dams? And we know that they are poor recharge. And then we took two dams, we studied them in details. We have climatic station in there. We have drilled some boreholes for observation. We measure the flow in the wadi at different position. And to our great surprise, we found that 95% of this is how there is a catchment like this, and the dam is here. In fact, the recharge will not happen near the dam. The recharge will happen all the way in the wadi. In fact, the first flood takes the top layer, which is silty or something, then for the rest of the flow, the water is really recharging the aquifer. The little water which remains behind the dam for a longer time, it is true, there would be some silt which is deposited. We tried also to solve this little water also to make use of it by opening gates so that the water go down, and then also we make some. Anyway, I think it was a very interesting lesson for me that we should not look to things from one angle. We have to see how it would. And then I found that why they are mad about it. Why also in neighboring countries like Oman, Sultanate Oman, also they build dam for this in other parts of the. And so I thought this is really very interesting and to study this. And then I tried to study what happened really in southern Saudi Arabia. They used to have to use, even from the time of the Prophet Muhammad and something, from the literature, they used to use something they call uqm. Uqm is not a dam. It is a high retarding structure. And so for southern Saudi Arabia, where there are more rainfall and there are more wadis, they asked Colorado State University to make a study. How could they develop this? It is also a form of water harvesting aspects in wadis. And what they did, they told them after Professor Sutu and his staff, they studied and they did the problem. They thought, no, you shouldn't build big dams. You have to make retarding structures. And the retarding structure along the wadi would make it better. And this is a system which was used thousands of years ago in the history of that part of the world. And in fact, I always mention to my students a story which happened more than 1400 years ago, that it, at the time of the Prophet Muhammad, that his cousin Zubair ibn al-Awwam has a farm. And then his uqm is the first uqm. And the one who is behind him, he made a complaint to the Prophet, telling him that Zubair is taking water. They are not allowing the water to come into us downstream. And then there was a question, how deep was the water used by the bear, which is really exactly the consumption use of the plant in that area. So also you have to look to the thing from a different angle. What is the purpose of those dams which you want to make? That was a lesson which I learned. I learned also while I was in Saudi Arabia there, and in fact, even after I was part, there is also a time of a lot, they did investigation for all possibility of groundwater. And they brought Sugria and many international companies, McDonald's and others, to look at different regions to see where groundwater is there. And then they made huge investment for people to start using this non-renewable groundwater for huge irrigation projects to be self-sufficiency in wheat, which is not really the main food. The main food is rice, really. But it brought the groundwater deep quickly. Two of my colleagues who work with me in this dams and in this water, they complained to the king that we are really depleting our groundwater. And a policy came out from the king, and I remember I came as a consultant with ESCWA when they are establishing their previous development plan to see, and they stopped all the intensives for the farmers, which are overusing and really abstracting the groundwater and doing those type of things, which is really not very sustainable. But what admired me is that the plan which they made for the 430. I mean, they have now a national water strategy in 2030 in Saudi Arabia. And I think it was really a model in any way. They knew that and they recognized that they have limited resources of exploitable non-renewable groundwater and low recharge rate, which is 2.8 billion cubic meter. And in fact, what they use is 24.8 billion cubic meter, which is really very little to what they are using. Agriculture is the foremost consumer of water, with 84% of total water requirement. Gaps in water sector policies and regulation, general inefficiencies is used. Anyway, they went and they studied all those things and they put objectives for their vision. And then they came out with a national water strategy, which I think it is very, very good. They think that water law and resource management regulation is important. Water resources management aspects in a form of IWR is important. Sector resilience, innovation and capability building and capacity building, supply chain efficiency and service quality, water service, saline water conservation corporation, which is bringing a lot of water. It has to be combined with that, and I will show you that this, if they leave it alone, it can create problem, distribution and restructuring of privatization. Anyway, I think it was a model work, but this brings me to another project, which I consider it is my main engineering project, which I'm very proud of it. And that is the rising groundwater challenge in Riyadh, Saudi Arabia. After I finished my second month at King Saud University in 1980, where we work on those recharge dams in the United, and I work in a wadi called Wadi Hanifa, which traverses Riyadh, this wadi, old wadi. Wadi is a water stream, which runs only during the flood time when there is rainfall and flood, but it goes inside the city of Riyadh, the capital of Saudi Arabia. When I left back to the University of Khartoum after my second month, there was a great period of drought. And this wadi has an alluvium, aquifers, and an alluvium of, in its maximum part is about 40-something meter depth. But this alluvium aquifer used to give the whole city, and the number was small and the people was little, their domestic water, but also it irrigates as a chain of gardens along the wadi within the framework of the city. What happened when I left in 1986? There is a drought. All this alluvium became 100% dry. So to get water for the farm of the people, they have to drill to the Manjur aquifer, which is about 1,000 meters or 1,200 meters down. In fact, the water comes from that level very hot. So you have to cool it before they give it to the very expensive exercise. But what happened? When I went back to Sudan, the guy who was used to be the dean of our faculty of engineering, Dr. Muhammad Abdali Sheikh, a great person, called me and he said, we have a problem. Could you take 2 months from the university and come to see the problem? And I went there. It used to be very dry. The wadi is dry. The city was dry. And in the study which we made for Wadi Hanifa, in the wadi within its catchments, there are 5 dams. But the rising ground, the water which is there in the city, the level of consumption, when you divide all the water coming for the city and divide it by the number of people, you will find that the per capita consumption is about 100 liters per capita. This is when I left in 86. When they called me, when I left in 85, when they called me in 86, I found a picture like this. You know, in very building, you'll find water coming out in the streets like this. Some of it with the smell. And the poor children, they go to school, they put some bricks in order not to go inside this contaminated water in the service. Not only that, part of the water is coming to the wadi. Some people are pumping or doing something. And so they told me, well, we have this problem. We don't want to give it at the time for a consultant. We'd like to bring your own team and see what is going on. Some they tell me this is some groundwater, which something came in a spring somewhere. And anyway, there are And we did a huge study. In fact, the picture was so annoying while I was there. For example, this is the kidney transplant hospital, Shemesi Hospital. And this is just one level down there. And within that level, the groundwater came there. And in Riyadh, in each building, there is an underground water tank for the sewage, and underground water, neighboring underground water tank for the water near each other. And this is in the hospital where there is kidney transplant and things like this. This is in a building where it has 3 levels of stories as garage and things underground. During my studies and the period, the water almost filled the whole levels, you know, the groundwater of the basement, which are there. This building was trying to build in the central part of the city, but in order to be able to build and to put a foundation which could resist the water, they are pumping 20,000 meter cube per water per day. This water goes down to the wadi. I think the good thing which they did is that they have a good storm water system developed for the city. And I remember when I was in the university, some of my colleagues, they tell, those people, stupid people, why do they make a storm water system and rain comes only once and comes in the very, you know, if that storm system was not there, the system would have been in great, because the water which is pumped is taken to the city. In fact, all the electric system, the piping there, if there is a hole, you can see the water coming out of it. The roads, luckily, I think they are very wise people. And then we worked and we knew what is the reason. I worked for years. We did a great hydrogeological studies using the best companies there, studying all the levels, all the type of geotechnical aspects, the wet water systems, the soil problems, and came out with an excellent study about the problem and how to solve it. One of the solutions is that in certain areas we cannot pump. We have to make really channels at certain level to withdraw the water and then take it to the wadi. In certain areas, we can pump. But then the water in the wadi, this is the wadi you can see, and this is the whole city mark, the one mark around this, that is the city really. So you can see the wadi is inside it, inside the city really. So the water which is coming in the wadi, it became really almost a river, perennial. There is a perennial flow. And the water is not clean. So they put a bio remediation system, which really cleans the water so that it comes to the system. And then now in Riyadh, there is a continuous flow in Wadi Hanifa, similar to and then the water go to a place called Al-Hay, where during the construction time, they dig huge holes and huge, and those became now like lakes. And so they made a development. This is during the floods, the rainfall, it become like this. During the summer, there is a continuous flow like this. So the water comes here to the wadi, and the wadi became something like this. This is now in a normal thing. If you go to Riyadh now and you look at it, and they made a fantastic study of how to develop this wadi. And as Professor Jamal yesterday spoke about difficulty of handling wadi, this is an example of wadi where the development came as an integrated development, looking at everything, in fact, at IWRM in action. And they got so many prizes for the good work they did. You know, this is the water coming to the wadi from different branches. They looked for a lot of things. This is the remediation system, where it cleans the water coming before it go and used by people. And then they made a lot of development. The wadi became something like this. People from Riyadh, this is a place where they can go during the weekend, during the night to see things like this. It's really a great work, and it's with a great effort. Anyway, I think I have to, this is I call it my life project. I was involved in it from 1986 until this day. I am involved also in its, because in the eastern part of the city, we told them if you develop this area, you will have a problem in a similar wadi called Wadi Sulay. And we told them this in 1986. They developed it, and now there is a similar project. In fact, the guys who talked yesterday, Professor Jamal and Professor Sheri, they work with me in developing a model in that area and how to manage the groundwater in the different aquifers. And I don't know how much is my time, but I have to run to the Iran experience. I went to Iran also as a UNESCO director to establish a new regional office, including Iran, Pakistan, Afghanistan, Turkmenistan, and so on, so on, so on. So But when I reached there after a few months, an earthquake happened in a city called Bam, and this has killed so many people. And then I found a system of groundwater management, which is so sustainable. It is Qanat. I knew Qanat before because when I was a professor at Saudi Arabia, we made a conference about what they call them there, Ayun and Aflash. And it is a system where you can take from the groundwater through a very complicated system like this one. You can see you can take the water. A Qanat is a system of water supply consisting of an underground tunnel connected to the surface by series of shafts, which uses gravity to bring water from the water table to the surface. And it is a continuous water. And if there is a time, I can talk for hours about the Qanat and my experience with it in Saudi Arabia and in Iran when I went to Iran. And so Qanat are usually dug where there is no surface water, and water originally invented by the Iranian. But I remember when there was one conference before I went to Iran and I was in Saudi Arabia, I fought with another Sudanese who was an ambassador there in a conference. What is the original of Qanat or Ayun or Aflaq? Is it in the Arabian Peninsula or Iran? I think it is a great human heritage, but I think the original most probably it is from the Iranian side. So the main or a mother well is generally excavated in the mountain, penetrating deep in the water table. Then water run down a slightly sloping tunnel, gradually increasing in volume until it emerged near the farms or communities. The immediate outlet, which is called Mashar, is the point where people take water for their various uses. Qanat technology exists, in fact, in more than 34 countries in the world. But the most enemy of Qanat is pumping. When they develop pump in many, even in the countries which I'm a director of it, and with Unesco, like Pakistan and Afghanistan and Turkmenistan, they used to have Qanat, but they destroy it by pumps. They put pumps on. But Iran, till this day, they have around 32,000 active system, which is a total discharge of about 9 billion cubic meters per year. Till this day. Also, Sultanate of Oman is one of the countries where they are preserving this unique sustainable system of Qanat. And in fact, a couple of Qanat, they became UNESCO within the UNESCO World Heritage sites, you know. The first recorded Qanat were in the northern area of Iran and date back to 800 years before Christ. But of course, the region where I became interested in Qanat was on December 26, 2003, where a powerful earthquake struck Kerman province in south central Iran, killing 26,000 persons in one day, and totally destroying the historical structure of the city of Bam. And the archaeological information reveals that the area is even more significant than had been. The area was the Arge Bam is a UNESCO World Heritage. At that time, it was a tentative list, but they told me it is from the list, so I called the director of UNESCO immediately. The Bam area seems to contain the oldest Qanat in Iran, and perhaps the world. Anyway, so Bam district is a typical desert oasis with an average annual rainfall about 60 millimeters. Perennial surface is non-existent, so there are a few permanent dry river beds. The district is surrounded by high mountains. There are some 3-7 pipelines of old traditional Qanat. In fact, they irrigate. The best orange in Iran used to come from this area. The discharge rate of the Qanat vary widely, mostly in the range of 50 to 20 to 200 liters per second. Geological studies have shown that the 2003 earthquake did not result in significant displacement of the fault scrap. However, it reduced significantly the amount of water diverted to farm, which required urgent action from UNESCO Tehran office, which I was the director of the office at that time. And UNESCO, and in the office, we took initiative. And our director general at that time, Professor Mr. Masura, he was really helped me immediately by giving me a significant amount, I don't remember, to help in this and to help in Arge Bam, the the cultural area, which people they go to visit and represent. So we help them really in bringing some of those canals in operation. This was carried out in close cooperation with GISI, HHU, with UNDP, with other aspects. So comprehensive report in the current status is there. We made a book, in fact, about that. This brings me to another experience. I don't know about my time now, but in any way, it is the Great Man River of Libya. Also, when I was the deputy vice chancellor of the University of Khartoum, they was called by UNESCO to be a member of a team to advise UNESCO, which was asked by Libya to advise them on the capacity building for staff for the Great Man-Made River. And this is the first time to hear about that. With me, there are great people, and I remember there was Farouk Al-Baz from NASA, there is professor from University of Iowa, there is Muayyid Ahmad, who is an American from Pakistan origin, who worked a lot in Libya, in the hydrogeologists. With us was Hasma from IHE Delft. With us was a great structure professor from Switzerland. So the team, we are acting as advisor to UNESCO what to do with the training, with that thing. So the Great Man River is an artificial river, in fact. It's not really a river. That was constructed to bring water from the underground aquifers in nearby empty southern Libya to the cities in the north. So it is really, it has to bring water 400 meters to the coast. Where it was, the idea was either to take people to the place of the water in the desert or to bring water to the coast, to people in the coast, with purpose of addressing the severe water scarcity in northern Libya due to lack of potable water, desalination problems, over-extraction, and deterioration of coastal aquifers with intrusion of seawater. 25 billion US, some they estimate the cost as 25 billion US dollar, largest underground network of pipes, 400,000 kilometers in the world, with 300 wells that supplies 6 million meter cube of fresh water per daily. The principal underground aquifer that feeds the Great Man River are the Nubian Sandstone Aquifer, Northwestern Sahara Aquifer, and Marzouk Aquifer. You can see them in the diagram here, the three aquifers, and they are shared aquifers. In fact, when we started this project, one of the countries of one of those shared aquifers sent a letter to the Director General of UNESCO and told them that the Libyans are taking water, but the water is fossil water, which was very far from the coast. So during our meeting, Muayyid Ahmed always claimed in a Jabal al-Akhdar, there are recharge, there are a little bit recharge, but definitely this water is really an unrenewable groundwater. And the idea by the Libyan is to use it also for irrigation. And this is not our work as advisor to UNESCO on capacity development, but we became so involved because the leadership of the project all the time is given to a prime minister. And you know, Gaddafi, at that time, Gaddafi thinks that this is really, and it is the largest project in his country. And so he put at its head, usually one of his prime ministers. For example, Al-Ghannouch, Mohammed Al-Ghannouch, really a very wise person. I remember Al-Ghannouch because we sat with him. And because whenever they need a need for travel, the other colleagues, they don't travel. So they leave it to me to travel. And so I visited Sarir and the places where those wells there. So we advised them, you know, how could you use this pressured water for irrigation? So they made a lot of preparation and they brought somebody with a PhD from Pro State University, Muhammad Al-Aqab, to start this project. And he's wise. We talked with him. Anyway, what happened is that luckily the wells in Sarir, which they started the first part with the Nubian Sandstone Aquifer, the wells, only 10% of them were, for a reason, bad drilling or bad, and so not a lot of water in phase one. There are a couple different phases of this project. Maybe another lesson which I read at a later stage, what happened is that they want to bring the water is taken to Tripoli, to Benghazi, but they give on the side to a lot of communities, you know, for animal resources, for domestic use, for industrial use, but agriculture use is minor. Yes, how much is left?
I would like to
Hello?
question.
How much? Huh?
Enjoy the presentation, but please summarize because we have a long list of other presentations.
No, I didn't hear you. Do I have a time or is it, how much time I have?
Please summarize so that we have a lot of other presentations, but we are really enjoying.
No, so my
So-
time is over, or?
Summarize in the next 5 or so minutes.
Summarize, okay, I will summarize. So anyway, this is an interesting project where there are aquifer regions, but we studied when they want to give Tobruk, which is another city in the sea, in the coastal line, by desalination. They ask us in Unesco to study the cost, and we found that it is cheaper to get the water from the groundwater in the desert and to put it there than to do desalination. Anyway, so I will go from this. I think for Unesco, I talked yesterday. Maybe what I need to add is that also it's my own experience, is that for doing Unesco's ISB 5 phase 5, I was one of the 5 who put in there, and I was happy that I pushed for groundwater and at risk, and came from it many initiatives in this project. One of them is MAR, Management of Aquifer Recharge, ISAR. We have IGRAC, and then you will have somebody talk about IGRAC. And I mentioned yesterday GIWA, which is, I like it myself because it links with some. GIWA is a global network to bring together regional network, and it was built in a network. I brought the picture of Mike Edmonds because he's one of the person who really helped a lot in developing groundwater in Unesco, and he died a couple of years ago. And I think many of our colleagues in Africa, they know him. We established, when I joined Unesco, we established a network on groundwater protection and another network on Wadi hydrology. Based on that network, Unesco asked us to establish arid zones because they said it's not only in the Arab region. You have to have a global, and then we did GIWA. And Mike is also one of the persons who worked with me together with Howard Wita, together with Soroshan in establishing this. Sudan, I think my 2 colleagues yesterday, they talk about it, Professor Jamal and Professor Shigiddi, so I will not really talk about it very much. What I would like to say, maybe inclusion. It was said by President Kennedy, anybody who can solve the problem of water will be worthy of 2 Nobel Prizes, one for peace and one for sciences. But I think if we want to invest, this is last one really, if we want to invest in the Nile Basin in our shared aquifer, let us do it. We have to do it, in fact, but under strict sustainable development goal and knowledgeable background to avoid disappointments. Groundwater is vulnerable to mismanagement, to contamination, to over-abstraction, to global and climate change. And I thank you very much for giving me this time and listening to what I said. Thank you.
Okay, thank you very much, Professor Bin. His presentation will be available on the link where you join the NBDF link. It's a very interesting presentation. You can go and do it because he's one of the most experienced people in groundwater, and listening to it is very inspiring in terms of the possibilities, the challenges, and the solutions that presents. So we'll move on to the next presentation by Dr. Christina Fraser from IGRAC.
Hi there, I'm just going to share my screen. Is that okay there? You can see everything?
Not yet.
Okay, I'll maybe just give it a second.
Okay.
Great. So morning everyone. Thank you for inviting me to present today. My name is Christina Fraser and I'm a researcher at IGRAC. Today I'm going to be talking about the building blocks of transboundary aquifer management and give some examples from my past work in Malawi. So I'll first look at the current state of transboundary aquifers in Africa, and then I'll move on to discuss some of the key building blocks to transboundary aquifer management. I'll then talk about the concept of prioritization and how this can assist in more directed transboundary aquifer management. And I'll give some examples of progress in terms of my transboundary aquifer management in Malawi, and then I'll conclude by bringing the narrative back to the Nile Basin. So this is a map of transboundary aquifers across Africa as we currently understand it. Just FYI, if I say TBA in this presentation, I'm referring to transboundary aquifer. There are 72 TBAs currently mapped across the continent, and these have been identified over years of global and regional initiatives and studies. One of the most important projects was the Transboundary Water Assessment Programme, where 300 of the world's largest TBAs were assessed. And this generated loads of information that's really helped increase understanding of TBAs, but has also helped to bring the importance of transboundary groundwater to the attention of the international community. Zooming into the Nile River Basin, there are 12 TBAs within the basin, and these range in sizes, use, and hydrogeology. It's also important to note that there are non-transboundary groundwater within the basin that could have transboundary implications due to being hydraulically connected to the Nile River. So what do we need to know in order to create a good foundation for management of these aquifers? First, aquifer delineation is essential. Where exactly does the aquifer extend? What borders does it cross? How deep is it? We still don't know for sure where all the transboundary aquifers are across the world. It is possible that there are many more than we currently know of, especially at the more local scale where studies have been quite limited. Hydrogeology data is also essential to understand the aquifer, how the groundwater is stored, how it flows. Hydraulic connection to surface water is also very important. Other aspects such as climate, environment, social and environmental factors should also be considered. Once collected, it's then important to harmonise this data across any borders. Another component of transboundary aquifer management is data sharing. Data collection within countries isn't particularly useful for transboundary management unless it's shared with all relevant parties. But how best to share this data? Web-based information management systems have become quite a popular method of hosting and sharing data recently. Member countries can upload and share data with each other and also decide how they want data to be shared with the wider public, with options to keep it private if they wish to do so. An example of an IMS is the Global Groundwater Information System, which has been developed by IGRAC. Countries and organizations from all over the world have uploaded and shared their data through this platform, open access. However, there's also options within the platform to create private areas for individual aquifers or individual projects. The GGIS also hosts the most up-to-date information on transboundary aquifers across the world. So if you're interested in finding out more about it, then you can head over to the platform and have a wee look around. There's hundreds of different data layers you can view through the platform, and it's very user-friendly. A really vital component of transboundary aquifer management is capacity building and increasing the awareness of groundwater. Because groundwater is invisible, it's often forgotten about or neglected in favour of its surface water counterparts. However, we all know that groundwater is vital for many things, including drinking water, irrigation, agriculture, ecosystems, climate buffering, many more things. Next year, we'll see groundwater being the focus of UN World Water Day. So that's a really great opportunity to bring groundwater to the attention of the international community and policymakers. Groundwater monitoring can play a key role in aquifer management, as water level and water quality data are often the first indication that something's not quite right with an aquifer. And again, this is linked to the importance of sharing data, because data from transboundary monitoring networks must be shared with relevant stakeholders in order to manage the system correctly. The final building block of transboundary aquifer management that I'll talk about today is cooperation. It's simply essential that if we want to see effective transboundary aquifer management, countries need to work together and cooperate. This importance has particularly been recognised in the Sustainable Development Goals. Target 6.5 is dedicated to integrated water resource management through transboundary cooperation. However, up until now, transboundary cooperation has been quite limited. In fact, most recently, a report showed that only 22 countries across the world have operational agreements over their transboundary water resources. And it's been recognised that there's still insufficient knowledge on groundwater systems in order to meet this target. So there's a lot of work still to be done in that regard. I'm now just going to move over to the concept of prioritization, which is a management approach that can be valuable in identifying both key areas for transboundary aquifer management and priority actions for management. When we think about prioritization within an aquifer, we need to consider what are the main concerns and pressures within the aquifer, where do we want to direct our resources, and are there certain areas within the transboundary aquifer that may require more immediate attention than others? Past examples of prioritization include examining aquifers for water quality hotspots, or identifying areas within an aquifer where there are particularly high abstraction rates that you might want to focus on. A case study I'd like to talk about today that focuses on prioritization is that of Malawi. This was actually part of my PhD research and was published last year. The Malawi case study can provide insights to the Nile Basin, as two areas in Africa share quite a lot of similar issues. Also, the majority of the aquifers in Malawi are fractured and weathered basement, and we see this quite a lot through the Nile River Basin. And there's also other important sedimentary aquifers, which we also see within the basin. Groundwater in Malawi is also really heavily relied upon, particularly within the rural areas. So for this study, the aim was to identify areas of transboundary aquifers within the country that may be vulnerable to over-abstraction or reduced water quality from contamination. We used data on hydrogeology, land use, water point type, the location of sanitation points, population data, the reliability of groundwater. And all this data was combined and classified on GIS. And the results produced a heat map of the country with areas that are considered high risk, shown by red and dark red spots. We then overlaid the risk map with transboundary aquifers in the area to identify which specific aquifers may exhibit problems. The results showed that there were 3 transboundary aquifers in Malawi that were of particularly high concern. There are 11 more smaller hotspots that may also be problematic. That was at the more local scale. The important thing to note from this case study is that now Malawi has the data to allow the government to focus its valuable and often limited resources into further understanding and managing these key aquifers of concern ahead of others that may not be as problematic. Once we understand what and where the key aquifer pressures are within a transboundary aquifer, we can then look at the more conventional management tools to intervene and improve the situation. Examples of what could be considered are conjunctive water use, managed aquifer recharge, borehole remediation, including stricter abstraction licenses, and many other options. Another relevant study from Malawi is the Sheri Conjunctive Water Management Project that was undertaken by SADC GMI and the International Water Management Institute. Here, a transboundary aquifer diagnostic analysis was done for the Sheri River Basin that's shared between Malawi and Mozambique and forms part of the larger Zambezi River Basin. Issues that arose from the diagnostic analysis were a lack of groundwater data, potential impacts on the basin from climate change, and clear evidence of diminishing water quality. A strategic action plan was then developed in order to plan how to best deal with these specific problems as a priority. This year at IGRAC, we're developing a set of guidelines in collaboration with Unesco IHP to assist countries across Africa in prioritizing issues and identifying key areas within their transboundary aquifers that may be of concern. We're testing the guidelines on 8 transboundary aquifers, and actually 2 of these are within the Nile River Basin. So we welcome input from all member states on this and the Nile Basin Initiative as well. We welcome any input from you guys. We're hoping that these guidelines will allow for better sustainable transboundary aquifer management across the continent. So just to bring it back to the Nile Basin, how can we rethink investment and strengthen cooperation in the basin with regards to transboundary aquifer management? Well, the most important recommendation for me is data. We can't manage what we don't measure. Collecting and sharing data in order to understand these systems as well as possible is vitally important. And the Nile Basin Conjunctive Management Project that was mentioned earlier will be a great contribution to this. Secondly, advocating for groundwater and bringing it to the attention of key decision makers, make the invisible visible. Finally, prioritizing emerging issues in key areas of concern will allow for more directed and more effective transboundary aquifer management. Thank you very much for listening, and I'm happy to chat further with anyone who'd like to know anything more or discuss any of the aspects that I've presented on.
Very much, Christina, for bringing that aspect on transboundary aquifer management in this discussion. Just a reminder for participants who have questions, there's a Q&A box down there that you can, where you can post your question. I also request the panelists to keep on checking it, and in case the question is directed to you, so already as we are moving on, you can answer within the chat, but we shall bring up these questions again at the end for you to run through them. So without further ado, we'll move on to the next presentation by Dr. Massa Mokla. Over to you.
Hello, everyone. Thanks
Hello.
for having me. And I am sharing my screen to start my presentation. Is it visible now? Can you see the presentation? Is it clear?
Yes, it is.
So, perfect. Well, thanks for introducing me. I am, give me a second, I want to select. Okay. I am Mahsa Mutlaq. I am a researcher at the Bonn Alliance for Sustainability Research, University of Bonn. And I am working in a project called Digitainable, and I'm going to talk about the navigating the impacts of digital transformation on sustainable transboundary water management, talking about innovative opportunities or disruptive risks. Well, going to the next slide, just going to give you a very short overview about the project that I am working on. The Digitainable is the combination of digitalization and sustainable. So we are looking at the complex relationship between the indicators of the Sustainable Development Goals and trying to understand the influence of digitalization and artificial intelligence on the SDGs progress. Then answering the research questions of what are the gaps in the sustainability agenda and how we can be that future sustainability strategies being developed considering those gaps being filled. So we're looking at it from the technical and social perspective to understand what is sustainability means and how we can promote it and reduce the challenges of these new digital technologies being there out to just impact the sustainability procedure. Well, I would like to start with a very short introduction about sustainability itself, how that terms came and how it started. Then we can just look at it from the throughout the history. That term started in the forestry domain by Hans Carl von Karlowitz, starting the question asking about how one can manage wood cultivation and usage in a way that the forest can be maintained in a good condition. And the solution was no more trees should be taken from the forest, then those can grow back. So the sustainability idea started from that time. And throughout time in 1987, Brundtland report started by Gro Harlem Brundtland, just developed the idea on sustainable development. In development, it means that it meets the present, it meets the need of the present generation without compromising the ability of future generations to meet their own needs. And they were looking at it from the social, environmental, and economic perspective. Building on that, in 2015, we know that it is the member state of United Nations just agreed on the Agenda 2030 for Sustainable Development, and then they created this International Community Convention on Global Challenges to solve it together, and came up with 17 Sustainable Development Goals, 169 targets, 232 indicators, and achieving them in 15 years to 2030. Well, the focus of our session and my presentation is on SDG 6, the one which is dedicated to water resources and sanitation, which has its own, sorry, it is just 8 targets as sub-goals. Well, coming back to the Sustainable Development Goal number 6, we know that for achieving that, it has like direct and indirect relation to all the other goals, and understanding those interrelations is helping us for achieving that specific goals and helping and supporting to achievement of the other goals as well. So we know that the water is like directly connected to agriculture, food security, gender equality, energy, climate, and all the others, and indirectly to poverty and health, and life on land and life below water, and so on. Just looking at that, understanding that interrelations help us to understand the water resources and achieving its security in a more sustainable way. Well, just knowing that water is one of the main centric ideas or components of the Sustainable Development Goals itself, and can't be reached, the water security, without understanding that to some level of the standard level of the other goals should be achieved. And it cannot just focus on one goal, and it should be understood in relation to the others. So we move on the other idea. Well, recently, in early 2021, World Economic Forum published reports saying that if you want to make progress on all major global challenges, then start with water. How to do that? So first, we have to start understanding what are the other global challenges are. So we are facing in the world that we have lots of different changes, sudden changes such as pandemic comes, and lots of other like the evolving changes such as social demographic changes, as like population growth, and lots of different social structures changes, geopolitical ones, economic challenges and changes, and technological ones, environmental changes such as climate change. All I want to focus here now is showing you that we have this challenge of urbanization, raising expectation from the social side, climate change, and disruptive technologies. How this technology changes is starting. We want to go through the Industrial Revolution with the first Industrial Revolution in 1784 by just mechanization, and that wave started. Then 1817, the second Industrial Revolution was more on the mass production and electrical energy being into the market. And then afterwards, Industrial Revolution 3 was just starting with automation and computers. And now we are in the face of Industry 4 revolution, which is we talk about cyber physical systems, we talk about the internet, and we talk about networks. Well, how it goes is that we started with digitization, with the process of automation, with the analog to digital. Then we have this digitalization, how to use the digital technologies to change the business models and market and make the revenue and economic dynamics being in a very new world and modernized. And then digital transformation. So we are somewhere in the history here, somewhere between digitalization and digital transformation. This fundamental change in the leadership culture, social and technical, innovative way of living, well, that's how it is. Now where we are here, understanding where we are standing and what the future is going to bring for us is something that we have to keep in mind and then be aware of. Well, now understanding all of those challenges, having these 17 goals to achieve, now we have only 9 years according to the plan, and where are we heading? Well, starting with how we are going to rethink this agenda of sustainability in the first place, seeing that all of those changes and all of those challenges being there, and what are the solutions? So what we can do is we have to make sure everyone is on board, so we don't leave anyone behind. And it is the plan, whatever we are planning to do is inclusive. And multidisciplinarity should be considered. Otherwise, if we are going to leave out some of the angles of looking at the same challenge out, so we are not going to go anywhere. So the idea is we have to make sure everyone's on board, so every stakeholder is included in whatever decision is going to be made for the society, for the environment, and for the shared resources that we have, such as groundwater resources. The focus is now, which I want to talk about, that how to better understand and evaluate the implication of different ways of using digital technologies in relation to SDG 6. And it is a specific target, which in the last presentation, we addressed that transboundary water target. It is, the indicator is that how many cooperative arrangements are out there in the transboundary basins as an indicator. So where are the main areas of influence of those digital technologies on that specific target, and how to identify the scope of risk and opportunities those digital technologies are bringing to the water sector? So we know, most of us know that there are lots of different innovative technologies out there. So we know that it is how blockchain is evolving nowadays and how the different way of smart instruments and devices are progressing, how big data and cloud computing is also just paving its way towards our decisions or the modeling, like future predictions, and lots of different products, smart products such as sensors, such as monitors, such as different devices are out there in the market. But where are they using and who are they? These are the producers. Who are the people having access to those technologies, and how we can make sure everyone have access to those, and these technologies are not becoming a new challenge in water resources management, and specifically in transboundary water resources. Well, for doing that in our project, we try to understand first what are those technologies are out there. So we categorize them into the data-driven, analytics-driven, design-driven technologies. So when we talk about mobile applications, blockchain, Internet of Things, and twin technologies, we talk about data-driven devices and technologies. When we talk about big data, cloud computing, artificial intelligence, machine learning, and deep learning, we talk about analytics. And design-driven are more about the visualization. So when we talk about 3D printing, or we talk about augmented realities and virtual realities. Well, now these technologies are out there. What are the services that they are providing for us? Well, the main areas of services are connecting and communicating. So we know that how our communication these days are affected by different platforms and the way that how it is evolving. So we can see that Zoom that we are using right now for connection. Monitoring and tracking. So we are having these monitoring systems, and then we are observing. There are lots of different data models, data generation models, platforms that we can use that. Analyzing and optimizing. So this is the same thing that artificial intelligence does. And then what we can have with different data series, and then how we can make the meaning to these huge amount of data generations. Then augmented and automated. So we have the robotics, we have different ways of, as I said, virtual reality to be in the market. Well, First of all, then we thought about now we have to come with the same understanding about those technologies, sorry. So we have to make sure that all the stakeholders come together to have a same understanding, same language, and same idea about these technologies and their sorry, I have just like have my throat a little bit like hurting. All the stakeholders being on board to make sure that we are on the same page and everyone knows about what is going to happen and what is going to be achieved through those technologies. We talk about research, policy, and society. Well, we started with developing a framework where when we are focusing on one sector, such as water, looking at SDG 6 as the main source and the technologies on the other hand. And I'm just going to just for a second mute my and then coughing and come back. Sorry. Well, understanding those technologies that I talked about already and knowing that these targets of SDG 6 is out there and how different stakeholders from technology, from research, from academia, policymaking can come together and see what are the opportunities and what are the risks each of this technology proposing to the targets of each of these SDGs, and now in the focus here, SDG 6. Well, we were having like a different platform, different dialogues, with gathering different stakeholders to come and see what is the level of awareness, knowledge among the stakeholders regarding the usage of these technologies in place and how they are seeing the potential. And then here, focusing on a specific SDG target, I can not hear but then anyway, so looking at the transboundary target here and seeing that what are the opportunities each of these technology can bring in, and is there any potential for change and having like a thinking out of the box alternatives for transboundary cooperations by having these technologies being applied for easing the way. Well, so this is the result of like some of the dialogues that we have. So everyone were very positive on the technologies can make the changes. And in some levels, they were just not seeing any connections, but the idea is still we are very positive and very surprised about these technologies. The idea is, yeah, of course, all of the technologies as a tool is very interesting, and most of them are very surprisingly easing our work. If you look back how now that we can have access to open source data, how we can use different platforms using modelings, geospatial platforms and tools, and how we can be very automated nowadays compared to before using our smartphones and just have access to any data we could have is helpful. But on the other hand, what are the challenges? So how to overcome that business as usual with digitalization, but not making that transboundary cooperation being added a new challenge to it, a new complexity to it. So we know how hard it is that cooperation on transboundary resources, surface or underground, is going to be very slow, and how it is going to be evolving in time, and it has lots of different complexities along with it. So how we can just make sure these technological advancements are not bringing another challenge to that topic and become an opportunity instead? Well, it is really hard to think about it. And the idea is how we can make sure these negotiations around shared waters can consider these technologies and make sure that they are not going to be a new challenge. Well, so we have to see what are these inclusion barriers. So what is just like stopping us for making the technology as an opportunity rather than that become a challenge? Well, we can ensure that not everyone's nowadays have the access and availability of the network or the devices. So as you see, affordability is high in some cases, so it's very expensive. Not everyone can have access to it. Not every nations, and if it's individual level, not everyone can afford it. And we talk about digital literacy sometimes. So even if we can afford and have access to the devices, but sometimes the competency and skill is not there to use those digital technologies. So how many of us can know how to use artificial intelligence and algorithms in new different ways and make sure that analytics that we are having as a result and outcome of those technologies is being used correctly or with the same language?
You could wind up in the next 2 minutes.
Sure. And then it is my last, one more slide I haven't.
Okay.
So then, and how it is locally relevant and about the security and integrity. So talking about the governance and political issues of the technologies and the security and privacy on the other hand. All of those challenges are some new topics bringing into the diplomacy and negotiation of the natural resources and shared waters. So we're having that in a project that we're looking at those things, and we make sure that when we talk about sustainability, digitalization in a sustainable manner, we have to make sure that impact on different sources and different domains is not going to be negative. And if we are going to absorb that change like soon enough, so we make sure that opportunity is not becoming the challenge that we are talking about. So we have to talk about universal targets and definition among stakeholders about talking about the same issue, the same understanding, the same skills, then understanding about the new organizations and institutional framework, and also talking about different models of digital work. So we need to have another sustainable development goal, talking about sustainable digitalization, which is going to be proposed for the new strategic way of sustainable development, hopefully in a few years' time. Well, thank you for listening. And well, we can achieve a lot more when we are working together rather than being individual. Thank you.
Okay, thank you very much, Musa. That was a very good presentation on the broader aspects of how the changes in all of the different fields are also affecting transboundary cooperation. So we move on to the final, I think, presentation today, and that will be made by Dr. Rosemary from IHE Netherlands on water diplomacy. Over to you.
Yes, thank you very much. So my name is Rosemary ter Horst. I currently work in Wageningen at Wageningen University and previously at IHE Delft. So I will present my work and analysis that I did both at IHE Delft and in Wageningen. And I've been asked also to focus on water diplomacy and water diplomacy tools. Also, in addition, for instance, to what was already shared by Mahsa on digitalization, and also by Christina on the tools monitoring and analysis of groundwater. And I think that we cannot, especially when we talk about transboundary groundwater management, water diplomacy and the relations between states is vital. So how do we build up and invest in these kind of relations and the communication between states also in this respect? So I will talk about what water diplomacy is, where the idea comes from, how it is defined, and what kind of tools are connected to water diplomacy. And I'm really happy that we are doing this in the MBI session, because for me, water diplomacy is the ultimate connection also between what is happening on the political side, the socioeconomic side, and engineering. And that is exactly where we want to go and are going in the water sector. So water diplomacy is addressing the challenge of governing water that crosses administrative boundaries. So as we see, surface water and groundwater, it flows, so it crosses boundaries. So it forces us in many different ways at local levels, between municipalities, between regions, and also between countries and federal states to work together and to discuss the water that flows either on the surface or underground between these administrative boundaries. And this water connects people with different rules and regulations, cultures, history, and resources. And that is also one of the biggest challenges, I think, that we that we have not addressed, but that actually several projects also in the Nile Basin are addressing. And I know of the work of IGRAC indeed and GIZ that are specifically targeting connecting the different rules and regulations also on groundwater. So what do you do if two countries have very different ways of managing groundwater, if they have different rules about the quality of it, if they have different approaches to monitoring? And that forces countries to come together and sit together and see at very different levels how they are going to connect and arrange communication between these systems. And as I shared before, water diplomacy connects the diplomatic world that is often related to negotiations, but also to etiquette. So in a way, the rules about how to behave, how to reach out with the world of water and often engineering. Although, as I said before, this is changing as many more different sciences and disciplines are involved in the management of water, including environment, geography, etc. And lastly, what I find very valuable about the approach of water diplomacy is that it forces us out of a hydrocentric focus. So it forces us to think about beyond water. It forces us to place water very specifically into the social, political, economic, environmental context and see it broader than only water. And I think also in the water sector, this is required if we want to manage it in a sustainable way. So water diplomacy came up in the water sector mostly at the Second World Water Forum, where it was also shared as a way to promote water security, in the sense that the thinking was that water cooperation would also lead to more and better management of water and thus to water security. And these ideas and the ideas of water diplomacy have been further developed also importantly at UNESCO in the PCCP program, from potential conflict to cooperation potential. And also here you can see that the focus is and was mainly on preventing conflict between countries. It is picked up also by donors to facilitate water cooperation, and also research on water diplomacy has increased since 2010. And what it is. So there are many ideas about what water diplomacy actually is, and often water security, water cooperation, transboundary water management are connected to it as well. But these are distinctly different things, albeit connected. But water diplomacy as a core is concerned with the management of relations between states over shared water resources. And therefore, when we talk about transboundary groundwater management, we cannot avoid talking about water diplomacy, because states are very central to these the management of shared water groundwater resources. And what water diplomacy then helps us to do is to focus on the process. So on communication, on fostering cooperation. And I will talk about the tools and approaches in a bit, and also connecting it back to what Christina has said. But water diplomacy and the management of relations between states is not only a matter of a state, it's not only a state's business, but there are different groups and actors involved. So the traditional diplomacy, we call track one. Then there is also the idea that diplomats are working together with experts. And this is one of the, I think, the main elements that we know also in the water sector, where scientists come in and they promote their ideas, they share their analyses, and they discuss together with diplomats and representatives of state on what would be different scenarios of managing the shared resources. Then there is also a way of groups and non-state actors, for instance, religious leaders or civil society representatives that can come together to promote and discuss how shared resources should be managed. And these kind of interactions can also influence states to cooperate. And then there is the idea that also people to people can connect. And for me, this is also a very important element, For instance, in Europe, I have been part of youth exchange when I was still young and studying. And this is also a way to connect people to, for instance, to allow students to go to another country to see what the water resources are like, how they are managed, by whom they are managed, and go back to their own country and use this kind of experience also later on in their professional life. So for me, the people-to-people diplomacy and these connections are a very, very important element and investment into state relations in the long term. So you see that there are many different aspects and people and experts and disciplines involved, all with the aim of managing relations between states. Then there are different tools that I want to highlight. So when we talk about communication, one of the aspects of diplomacy that we are very aware of is negotiation. Then at the moment where relations between states are difficult, it is possible for a third party to shuttle between different states to bring across messages. And I think also in times when communications are difficult, this is a very important element. In the water sector, we also see that cooperation over water is often possible, also at a technical level, even when relations between states at a more political level are challenging. Then analyzing systems is also an important part of water diplomacy, and this connects closely to what Christina has said and shared on how shared groundwater resources are monitored and analyzed. So this can be fact-finding, but also an analysis of human systems, so stakeholder analysis, conflict analysis, and preparing for negotiations and knowing what the other party, how they manage groundwater, what kind of rules they have, what kind of regulations, how dependent they are on the resource, all helps to get an idea and a sense of how to manage these shared resources together. Then in the context of cooperation and conflict, an important part of diplomacy and communication is not to avoid conflict. So that's not the idea about it. It's to avoid conflict to turn into something violent, something that cannot be managed anymore. And sometimes conflict can be good. Sometimes just clashing can be good as long as you manage it in a way that you are managing in a respectful way. And dispute resolution mechanisms help to do that. So this can be going to court, but also negotiation or mediation or arbitration, where third parties come in to help to reach an understanding. What I find an incredibly important element, also in terms of groundwater, especially because it's a hidden resource and often there are so many unknowns related to it, is joint fact-finding. Also as an element of trust building. And in joint fact-finding, oftentimes in these processes, countries come together and they agree on a certain approach on how to monitor and assess a joint resource. Special about joint fact-finding is that oftentimes at the beginning of this process, the countries agree with the outcomes. So even if you don't know what the outcome of an assessment is, and even if it's not in your favor, you agree actually to accept the outcomes. What I want to highlight also is that water diplomacy is not a standalone. It's connected to institutions. It's connected to physical institutions, but also to cooperations such as SADC, such as IHP, such as the work of IGREC is doing, such as the SADC Groundwater Management Institute, but also connected to law as an institution. And the legal institutions can provide guidelines on how to manage water. So it can provide you ideas about how other countries approach the shared management of these groundwater resources. And as emphasized already several times, is groundwater is hidden and sometimes forgotten, although there is more and more attention to it. But still, international legal principles are not agreed on. So in 2008, the UN Law Commission presented the draft articles on the law of transboundary aquifers. And these aim to provide a basis for negotiation for specific aquifer agreements. So they provide guidelines, ideas to countries and say, okay, you can use this, you can use this for joint management regulations. But these have not been agreed yet at the UN level. So what I want to share with you is that although there are ideas on how to manage it jointly, these are not globally agreed on. So countries have to figure out themselves how they share these hidden groundwater resources. And then institutions as the SADC are really important in contributing to this. And I wanted to end with sharing a few lessons learned from other processes on transboundary water management. And these are surface water. This is surface water management, but I'm sure it's also related to groundwater. And one of the most important lessons and insights is that it takes enormous time to build up relations, that it takes time to build trust, and that this also takes time to collect the data and then feed it back into political processes and vice versa. And oftentimes what we see is that projects are too short to allow for really long-term relations to be built up. So one of my own insights would be that rather for projects to take 5 years, we should invest in 10 or 15 years processes, which again links to the importance of institutions as the NBI and SADC. So it takes political wisdom and courage to foster positive developments for the benefit of all riparians in the basin. If you don't know what a resource, how much water you have, how much groundwater you have to take some risks. And sometimes you have to show your cards or your intentions earlier than your neighbor to take a step forward and to offer what you want out of a negotiation. As I said before, these analyses are incredibly important. Understanding your neighbors, understanding what they want, understanding what they need, understanding how they use groundwater, how they are dependent on it is also vital for negotiations and for achieving joint agreements. Again, thinking long-term is really important, but prepare for opportunities to come up. In case you have achieved if there is a political stalemate on other aspects, it might be that you actually can reach agreements over surface water or groundwater, perhaps because it's more technical, because it's less sensitive. So looking for these windows of opportunity and prepare for them is key. And then it's not about state-to-state relations alone. As I said before, it is about many, many different levels that work together and that are also dependent on groundwater resources. So cooperation is a multi-level game. And that is also what makes it, that provides opportunities, but also makes it more difficult. So who do you need to take into account? And at what level can you take decisions? And that differs per country, that also differs per political system. And then lastly, I want to end with the importance and emphasis on how it is good to combine diplomatic and technical expertise. And this is not only at state-to-state level, but applying these tools and insights from water diplomacy at different ways of different levels and managing groundwater is vital. So we need to get out of our hydrocentric focus. We need to connect to different ministries, to different communities, to different disciplines. Thank you.
Thank you very much, Rosemary. That's the final presentation that we have today. I wish to thank all the panelists who have presented so far. Thank you very much for taking time to prepare the presentations and also delivering them. In summary, yesterday we looked a lot at the science related to groundwater management. Today we've looked more at the management issues and how to make groundwater an important part of the discussion around water resources management within the Nile Basin. So we are moving into the session for discussion. We have about 15 minutes to complete the discussion session before the end of the overall session. Questions were asked, but unfortunately we lost power briefly, and over here at NBI we don't have access to all questions. Though I put down some of them. But before we move into that, there are two people I'd like to make a comment. One of them is Mr. Crispin Juma, who is our governance member at NBI from Kenya. I'm requesting to make a brief comment about how the countries really view the importance of groundwater in the overall water resources management in the Nile Basin. Crispin, are you with us? You can unmute.
Hello, Kiza. How are you?
Yes. Thank you. Well, I'm well, thank you.
Good morning, good morning.
I would like you to make a very brief comment. We know this is the first groundwater session probably under NBDF, and we just felt that we could get the viewpoint of the country in terms of the importance of groundwater in the overall water resources management in the Nile Basin. Very brief. Thank you very much.
Thank you very much. And I want to thank the presenters this morning. Very interesting presentation, especially the final one on diplomacy, hydro-diplomacy. This has always been a very interesting topic for us in the Nile Basin, because in the basin, you know, it's about diplomacy. We have to resolve some of our issue diplomatically. So I want to thank the last presentation for very interesting perspective on hydro-diplomacy. Coming back to management and development of water resources in the Nile Basin, specifically looking at groundwater. One of the issues that the Nile Basin Initiative has been advocating is the conjunctive use of surface groundwater, so that we balance the two resources. Where we have a strength on groundwater, we focus on groundwater. Where we have strength on surface water, we focus on surface water. Although I must also hasten to add that in the basin at the moment, we don't fully understand our potential, the potential of groundwater. And these are long shot. We've been trying to understand fully the groundwater potential in the basin, but it's work in progress. For example, now we have isolated about 3 shared ground aquifers for detailed study, which is an ongoing process. But I just want to mention that for us as a technical advisory committee members, we really want to advocate for the conjunctive use of surface and groundwater, and really encourage in areas where we have strength on surface water, we focus on surface water. Areas where we have groundwater, let's focus on groundwater. Given that groundwater resources are strategic reserves, they are strategic. We use them when surface water is totally lacking. Even though in this particular area, we're dealing with the Nile Basin, Nile River, which is surface water, but you'll find in some of our areas, the level of pollution or sedimentation is high. And therefore we have to either deliberately recharge through filtration into our groundwaters, then use the groundwater when it's potable enough. So this is the brief comment I wanted to make about management and development of water resources, just to emphasize that our groundwater potential is not fully established. And therefore, even as we're using groundwater, let's not mine it. Let's not mine our groundwater resources. Let's be careful, use it optimally. Thank you very much.
Thank you very much, Mr. Juma. The second person I'd like to request to make a
Thank you very much, Kiza. Thank you.
Oh, welcome. The second person is Dr. Vladimir Mamaev. He's the Regional Technical Advisor for UNDP at the Istanbul Regional Hub, and also the Technical Advisor of our Groundwater Project. I'd like to request him to make a brief comment again about the viewpoint of UNDP in terms of this project.
All right, thank you very much, and good morning, everybody. It's quite an interesting session that I attended today that started with a short presentation of the project. And I think that this project is extremely needed project. And this is one of the few groundwater projects supported by GIF and UNDP. And we have been waiting for quite a long time to initiate this project, and now we are starting at implementation. Unfortunately, we are starting it in the very difficult time for everybody. And again, we are Zooming instead of having fun in Entebbe. But I hope it will come. It will come. The most important thing is now for Nile Basin Initiative, together with the project manager, to start the activities that could be started now. Of course, we fully understand that several on the ground or field activities cannot be started. Some of them could be started. So it's a judgment that is with NBI and the project manager. And of course, from the UNDP side, we're ready to help. As you know, of course, we have the in each of the country, we have the country offices that are ready and stand by to assist this project implementation. We have the Istanbul Regional Hub, where I work, where I am located, and we have, of course, the global water and ocean governance team that is ready to assist in the implementation. So again, thank you very much for a great session. Really very interesting. All of the presentation. I mean, I like them very much all, and I hope that it will be possible to get the presentation itself, not the recording. The recording is one thing, but I would like also to see the presentation themselves separately. It's very interesting, and good luck for the young people that are doing research and doing PhD. And I remember when I was doing a PhD, at that time we didn't have such a number of transboundary projects that we can take as good or bad examples. So good luck to everybody. Good luck to the project team. And of course, good luck to the NBI for organizing such amazing and interesting events. Thank you so much.
Okay, thank you very much, Vladimir. So now we move back to the questions that were asked. I'll request the panelists. There were several questions asked. I captured some, but maybe you captured others. But I'll leave it up to you. It's an open discussion. If you want to answer any of the questions. There was a question, for example, for Professor Bill on the issue of pollution in deep aquifers. If you can address that. Okay, and then maybe he will join. Then there was a question for Christina. What are the technologies that are available for sharing water resources in the Nile Basin, for example? Christina, you could start. But yeah, it's open, really. If you capture.
Sorry, I'm not. I think the technologies question was directed at Masha.
Okay.
Can you ask the question once more?
I can read it. I can see it.
Which one are you referring to? That's what I was looking for.
I think it's the one in the chat. It says which technologies are available and affordable in the context of water resources with regard to the Nile Basin.
Well, it is a very general question. So, I mean, we know that there is no limit to technologies that we are using already, and the ones which are going to be kind of innovated. So, but then which one is going to be used or how it is something that our project managers and coordinators in the groundwater project should address that, because there are many that can be usable, but choosing which one for what purpose and how to make the capacity for it and how to teach to the people in the area or people working in the project is something the choice of the project manager and like the regional projects normally. So then, but knowing what technology is out there is something that also, I guess, a challenge for the project managers to know why, how, and how, like, the expenses and costs are, and how much like expertise it is needed for that technology to be employed. So these are, I guess, assessments that like when the project is designed, these are the things that should be considered, and it should be also planned for. I guess Maha can add something on that. So I guess this is something that you're already having in plan to see what kind of technology that you are using, what kind of platform, what kind of tools, and so on, data sources.
Okay, thank you very much, Masha. Basically, if I can add on some more information related to the Nile Basin groundwater project. Of course, the technologies that you choose for managing any resource depend a lot on the information you have, how the resource is understood, the capacity of the people that are going to use these technologies. So we recognize, for example, in the Nile Basin groundwater project that, of course, the very major problem that we have in the basin is availability of data and information on groundwater. So at the very start, we'll start with the first component, which is around improving the knowledge base. So we shall be collecting all that information that is available and using a lot of remote sensing sources, because there's no other way to get some of this information about aquifers, characteristics, extents, and so on. And yet remote sensing has evolved so much. So that is a very, very major part of the whole story. But embedded in there to address the issue of how to go about it is a series of pilot projects that we've selected. Some of them are related to groundwater recharge as a way of sustaining the resource. Others are related to water funds as a way of encouraging upstream users to protect the resource as opposed to depleting it, and then groundwater, the downstream ones can pay for the resource, and others. So different approaches to the management of groundwater are going to be piloted with the idea of selecting those that can be spread up into to country level or to aquifer level, and finding out how it can be done really in such a basin. So there are lots of different ways to approach it, and like Masha said, it all depends on the specific characteristics of the project, and we need to select which ones are applicable. Panelists, are there other comments you would like to make? Those are the only questions I captured because power went off, but if you remember some others, that would be good. You can address them.
There is one question for me which I can answer, I think. But with regard to the tools and digitalization, I think what I want to add, and also from a view of water diplomacy, is how important it is to agree on what kind of what you want to achieve with the data collection and what you want to achieve with the application of digital tools. So what is the end goal that you're working towards? And I think also with the digitalization and the powerful tools that we're having, more and more data is collected, of which we sometimes don't, that we sometimes also don't use. So making sure that you know what you're working towards is crucial in this effect, and also where you want to invest. And I think that is going to be the challenge of the coming years. And there was another question on water diplomacy in groundwater and how we can take into account the interaction between surface waters, transboundary surface water and groundwater. And I think the fight in the field of transboundary groundwater was to also acknowledge groundwater resources that are not connected to surface water. So groundwater was always connected to surface water in the discussions, and now more and more, and I think also due to the work of IGRAC, for instance, and IHB and SADC, also these standalone aquifers are acknowledged as important resources that we need to manage. So I think the fight also for bringing groundwater to the attention of states, to the attention of different actors is continuing, and we have to make sure that it on the agenda and that research continues.
Thank you. Thank you, Rosemary.
Can I add on Rose's comment on the digitalization and diplomacy? There will be also one session on diplomacy. I guess it is on 4th April. So we just also have the topic on talking about how the topic of digitalization can be added into diplomatic procedure and what new topics can arise for the stakeholders and negotiators to focus on and add into their process of negotiation. So this is also, if someone's interested to know it in more detail, that could be something that we are going to talk about in that day.
Okay, thank you very much. There's also a question on riverbank filtration in Sudan. I request Maha, would you like to comment about that?
Yes, I can see that Dr. Jamal, Professor Jamal is with us. Professor Jamal, will you open your mic, please, and respond to this question?
I think Professor Jamal said earlier in the chat that he has no connection to. Oh, he has, sorry.
Yes, Professor Jamal? Yes, he's there. Jamal Abdul. Hello, Professor? There.
Professor Jamal, you can unmute. Okay, as he's doing that, maybe there's also a question on whether the training and capacity building is part of the Nile Basin Groundwater Project. Yes, there are two very important components of this in recognition of two very important challenges. One of them is related to capacity, and we have a component on capacity building, which will target trainings, which will target joint learning of professionals within the basin from the different countries coming together, sharing lessons learned and experiences in terms of groundwater management. So there's that component on capacity building. There's also another component on awareness raising and publicity, because we recognize that the importance of protecting groundwater from pollution and overexploitation. That knowledge and information is not really well spread out in the communities. And yet they all face the same challenges as surface water sources. Sometimes it is, of course, I remember there was that presentation, I think, by, was it Christina? Highlighting the issue that groundwater cannot be seen. So sometimes we are polluting it or we are overexploiting it without knowing. So we have a component 5 under the project, which is really just about raising awareness about the importance of protecting groundwater from pollution and overexploitation. Those two are meant to really ensure that both professionals and the general public know more about how to best manage this very important resource.
If I may respond to
Yes, Maha will respond to the question about riverbank filtration.
Yeah. Since Dr. Jamal is not responding, there has been many trials on this riverbank filtration. The last one was at the Heights, Roseris Dam at the city of the Heights. And it was mainly regarding reducing turbidity of water, but not real filtration. Some trials were done on the Hafir, that is the big wells on the water harvesting projects. But it majorly concentrates on reducing turbidity rather than dealing with other problems regarding quality of water or quantity of water. Thank you.
Thank you very much, Maha. So we are coming to the end of this discussion. All the questions I can see have been responded to.
Christina, would you like to add?
Christina, would you like to give some closing remarks and before we close?
Yeah, I would could just follow up on some comments that were made about groundwater that's not connected to surface water. And it's totally true that these aquifers that until now have kind of been ignored a bit, and the importance of groundwater that's not connected to surface water hasn't really been appreciated in international law, but those things are starting to change now, and it's particularly important because often these resources can be the most vulnerable, especially if they're not recharged, then they can be very easily overexploited. So it's great that they're finally getting the attention and the management that they deserve. So I think I'll just close on that comment.
Thank you very much. And that brings us to the end of this session. I wish to thank you all, the participants, for bearing with us and actively participating in this session. And I wish also to thank the panelists for your insights into groundwater management in the basin. We'll be contacting most of you because as we move into the implementation of the Nile Basin Groundwater Project, we are all partners in this and we shall be in touch. Thank you very much and have a nice day.
Thank you.
Thank you.
Thank you very much.
Thank you,
Thank you.
everybody. Duma, hi, how are you?
Hi, Abdin.
Fine,
A long
thank
time,
you.
long
Are
time.
you?
You know,